So in this video, I need to talk about the concept of convergence and divergence of a series. This is a difficult thing to do. In fact, the next 8 or 9 lessons are about how to determine if a series converges or diverges. But before we can even start talking about how to do that, we need to talk about what it means for a series to diverge. So first recall, we already know that a sequence converges if the limit of its terms converges to a finite value. In other words, a sequence will converge if the limit of that sequence exists, if the limit converges. It's a very, very simple thing, right? So determining if a sequence converges is a very, very simple thing, right? It's hard to tell if a series converges, and let me give you an example of that. Actually, if we take the example from the end of the last video we did, we had a sequence whose n equals 0 term was 1/2, the next was 1/4, the next was 1/8, the next was 1/16, the next was 1/32, and so on. It seems pretty clear that this sequence converges, right? Because as I continue to go on in the sequence, the terms are just getting closer and closer to 0. And in fact, if we look at the nth term for it, we can tell pretty clearly that as n approaches infinity, this whole thing is definitely going to turn into 0. This sequence converges. But what about the series associated with that? That's a harder question. The question I'm going to get at in this video is, if I were to take 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 and did this forever, would that series converge? What does it even mean to say the series would converge? And that's what I'm going to be getting in this video. That's what we're going to be talking about here. So here's a definition for us. If you want to know what it means to say a series converges, this is what it means. In the next 9 or 10 days worth of lessons, you're going to be learning lots of ways to find out if a series converges or diverges. But this is the definition. An infinite series converges if the sequence of its partial sums converges. So the definition of a series converging is that if you looked at the sequence of its partial sums, that sequence converges. If that sequence does not converge, then the series diverges. Okay, so I would kind of like to take a look at that with the example we've had running through this. And so here is this conceptual example, right? Think about the sequence that we had at the end of that first video, right? We know that the sequence, like I mentioned before, is 1/2, 1/4, 1/8, 1/16, 1/32, and so on, right? If we want to know if the infinite series converges or diverges, what I'm going to have to look at is I'm going to have to look at the sequence of partial sums. I'm going to have to look at the sequence S0, S1, S2, S3, S4, and so on, right? So, S0 is 1/2. We even saw in the previous video, it was 1/2, it was 3/4, it was 7/8, and I could keep going for you. It'll be 15/16, and then 31/32. And the question is, if you want to know, does the infinite series converge or diverge? What we can do is we can look at the sequence of partial sums and determine, does that thing converge or diverge? Based on what I'm seeing here, it looks like our series converges to 1. So, like I've said a couple times, the next 9 lessons or so are going to be about us finding ways to prove that a series converges. But when we say that a series converges, it means that the sequence of partial sums is converging. While I'm here, I would like to throw in one more interesting thing about this series. I can give you a conceptual proof of why this series actually does converge, right? Think about this, I guess, graphically or symbolically, right? Imagine that you had a box, right? Here's a box. And the first thing I'm doing is I'm saying 1/2. I'm going to fill in half of the box, right? Then the next term tells me to fill in 1/4 of the box. The next thing tells me to fill in 1/8 of the box. The next thing tells me to fill in 1/16 of the box. The next thing is 1/32 of the box. And very quickly I'm running out of accuracy with my finger here to shade these things. But the idea is, if I repeated this process infinitely and kept shading in 1/32 and 1/64 and 128th, if I did that infinitely, my sequence of partial sums is going to be getting closer and closer and closer to filling in the entire box, which means I'm getting closer to filling in my one full complete unit. That's what it means for a series to converge.